of what happens when we're talking about oxygenation and ventilation and how they are two different processes. So our students used a pulse ox to really take a look at what happens when you hold your breath, what happens when you breathe too fast, and we were able to use a waveform capnography and create the same issues wearing end-tidal CO2 and see what happened. And it really, I think, helped put together the aspect. So let's take a look at exactly what it is they did. Our summer EMT class, as we have people now saying hi. All right, so our summer EMT class had a question in relationship to using a pulse oximetry, and we were wondering, or they were wondering about a pulse ox and whether or not the pulse ox reading actually changes if you hyperventilate or hold your breath. And we were talking about the difference between oxygenation and ventilation. We have a finger probe pulse ox. We had a pulse ox reading initially was right there at 99. Okay, so go ahead and she can get to hyperventilate. We're having her sit.
Yeah, I feel stupid. Keep going. Yeah, I'm gonna pass out, dude.
Okay, so we stopped there. She felt like she was gonna pass out, and then our heart rate went up to about 94, maybe. Pulse ox stayed the same at 99. So that means that apparently when you hyperventilate,
Nothing changes.
nothing's gonna change. Okay, at least on the pulse ox. No, this is science. Now, part 2 of the experiment. So he's gonna exhale out, and he's gonna basically hold his breath. Okay, so let's see what we got here. Okay, so he's at 98. Okay, go ahead when you're ready. Oh, he already did it. He doesn't follow directions very well, but.
All right, yeah, I can't breathe. My blood pressure, my blood pressure, my beats per minute dropped, though.
Okay, so looks like after all that, his pulse ox stayed the same as well. So right off that, what did we find out? What would be the conclusion of? It's not reliable. Nothing changes, so the pulse ox actually is not going to change when people are holding their breath or hyperventilating. We have hooked up our end-tidal CO2, and we have this non-invasive end-tidal, so it's a nasal cannula. So keep in mind that the end-tidal, but this end-tidal that is here is going to give you the maximum number within 30 seconds. Okay, so this waveform here is actually something that's going in real time. So go ahead and hold your breath. Keep holding it. Keep holding it. Go ahead and breathe. That was 30 seconds. That's when the apnea picked it up. How long were we sitting there? Now look what happened to her end tidal. It actually came up to 40, was our first one. Why would it have come up that high? Why did her end tidal CO2 reading come up from, I think it was 29 to now it's at 40?
Right.
Yeah.
You hold on to it. Absolutely.
So now you're going to hyperventilate. So that means that you're going to have to breathe fast so that she gets her breath. Okay, go ahead. Are you feeling any tingling?
Okay. Yeah.
Okay, go ahead and stop. She's getting tingly. So what happened is that she's dropped now. She's down to 24. So she dropped her capnography reading down. Now she needs to take some breaths. And her heart rate, I'm sorry, her respiratory rate at one point was up about 80. So now she's trying to, now you're probably feeling lightheaded as things are starting to go back to normal. No passing out.
No.
But if you notice that her pulse, it's tough, I know I moved it. So her end tidal is actually starting to go up a little bit. So now we're back to about 26. Her heart rate was over 100 at one point. That's starting to normalize. But her pulse ox still stayed the same. Her respiratory rate's now down to 13. So she's calming down. So now what did you just see? Difference between oxygenation, ventilation. One measures oxygenation, the other one's measuring ventilation. So when a pulse ox is normal, what does it tell you about ventilation? Nothing.
Really nothing now.
It only measures oxygenation. Okay, you guys want to wave bye now?
We did that little experiment in class. From a student standpoint, I really hope that it helped identify the differences between what oxygenation is and what ventilation is, because they're two separate entities, but they work together. And for us to take care of our patients better, if you recognize that there's a ventilation problem, how do we fix that? How do we improve the way that the person's ventilating? And if we do that, a lot of times we fix the oxygenation problem.